So let's begin constructing those theories. And I'm going to start with a very important concept, the concept of the production function. And almost all, actually probably all, economic models of economic growth start with this very, very important analytical device. As you'll see, when we speak of the production function, what we're talking about is a very simple representation of something that in reality is incredibly complex. That is, how do firms bring together factors of production in order to produce output? It's a really very fundamental, basic way of thinking about what a firm is. A firm is an organisation that exists in order to bring together various factors of production, and in doing so, to produce output. And we're going to deal with very simple production functions. As a lot of economics is, it's a very simplified view of reality. But remember that when we simplify things down in economics, what we're doing is really trying to get at what are the key basic fundamental forces at work. So a very basic production function consists of two factors of production only. Labour, so that's you and I, workers, and capital. Now, capital is one of those words that economists use in a very precise way, and it's not necessarily the same way that non-economists use it. When I speak of capital, I'm talking about the plant and equipment, the machinery, if you like, and the factories, the physical, tangible infrastructure and equipment that firms use in order to produce output. And you can think of a firm as bringing together these two factors of production, combining workers with capital, or combining capital with workers. The two are very closely intertwined in order to produce output. Labour and capital collectively are often known as the primary factors of production. They are, of course, not the only factors of production that influence firms' ability to produce output. There are a whole range of what we will call secondary factors of production. And secondary factors of production comprise anything other than labour and capital that influence firms' ability to produce output. Examples might be technology. Not just the machines that are available to firms, but how good are those machines? What is the level of technology that is embedded in those machines? Or it could be the skills of the workers. That would be another secondary factor of production. A firm may have 100 workers available to it, but the amount of output that can be produced using those 100 workers may differ according to their skill level. It might be the climate of the region in which the firm is located may have an influence on how much production can be achieved. It could be anything at all. So secondary factors of production, it's not possible for me to write down a list of those secondary factors of production because it literally encompasses anything and everything other than the primary factors that influences output. So we're going to delve into much more detail about the production function, but please don't lose sight of the fact that it's really a very simple concept, a very sort of gross simplification of something that is extraordinarily complex, how firms produce output, It's very much based on this idea that firms exist to bring factors of production together, and in doing so produces output. Our focus will often be on these primary factors of production, but you'll see that the secondary factors also have a very important role to play. What you're looking at here is something known as a production table. A production table is one way of representing this idea of a production function. In a production table, what we do is essentially conduct an experiment where we vary the amounts of labour and capital whilst holding any and all secondary factors of production unchanged, and then we record what happens to the output that can be produced. So just to repeat, a production table, we vary the amounts of labour and capital available to the firm, we hold all secondary factors of production constant, and then we record how much output is then produced. In this example of the production table, I'm conducting a very specific experiment. Here, I'm holding not only the secondary factors of production constant, but I'm also holding the amount of labour constant. And then I'm going to vary the amount of capital that the firm has, starting with 1 unit of capital, through to 2, through to 3, 4, 5 and 6, and then record how much output is then produced. So here I'm going to hold labour fixed. I'm certainly holding the secondary factors fixed as well. And I'm going to vary capital. Now it's conventional in macroeconomics to use the letter K as our symbol for capital. And I want you to look at those numbers and look at them very carefully, because they are consistent with a characteristic of real-world production functions that we often observe. This is a characteristic known as diminishing marginal productivity. In this case, because it's capital I'm talking about, we would talk about the diminishing marginal productivity of capital. What does this mean? Suppose we start with capital equal to 2, so we have 2 units of capital, and then we vary it. We increase it to 3 units of capital. From the table, you can see that there will be a change, and I'll use the Greek letter capital delta as my shorthand notation for change. There's going to be a change in GDP in this case equal to 0.83. You can see that from here. So we've increased capital and we've gotten some more output. In fact, we've gotten 0.83 extra output. If you repeat this exercise, this time starting from K equaling 3 and moving from K equal to 4, then from the table you can see that, yes, once again, output does change. Changes by 0.54. And compare those two numbers and you'll see what we mean by diminishing marginal productivity of capital. The extra output that has been produced as a result of growing capital from 3 to 4 is smaller than the extra output that was produced when we grew capital from 2 to 3. And if you repeat this exercise, you'll see that that is a general characteristic of these numbers. That as we grow capital, holding labour fixed and holding all of those secondary factors fixed, we do get extra output, but we're getting a diminishing amount of extra output. What's the intuition behind that? Well, Think about it. Think about if you were this one worker. You're quite productive when you get your one machine, but then if you suddenly have two machines available, yes, you can produce more output, but it's going to be not necessarily that easy for you. You have to rush from one machine to the other machine, and so the amount of extra output you get from having that second machine is not as great as the extra output you were able to produce when you got that first machine. Then you're given a third machine. You've now got three machines to keep operating. You're running from one machine to the second machine to the third machine. Yeah, you're going to get some extra output, but you're probably not going to get that much extra output from the third machine, and so on and so forth. So diminishing marginal productivity of capital with a fixed amount of labour, adding to the amount of capital that is available, gets you more output, but diminishing in the sense that we're getting smaller and smaller increases to that output. So let me just summarise, because I introduced a few terms there that I just want to make sure that we well and truly understand. You'll hear economists talk a lot about the marginal product. The marginal product always relates to a particular factor of production, in this case the marginal product of capital. What it represents is the extra product or the extra GDP resulting from a small increase in capital. And we usually think about it as a 1 unit increase in capital. How much extra output do you get from that additional unit of capital? When we speak of diminishing marginal product of capital, what we're essentially saying is the marginal product of capital, and I'll now use the shorthand notation MPK for marginal product of capital, declines as the amount of capital increases. Please don't get confused about this. We are still getting more output. It's just the extra output we're getting, the extra product we're getting, is diminishing as we increase the capital stock, remembering throughout all this, and this is crucial, we're holding labour fixed and we're holding all of those secondary factors fixed as well. The only thing that is varying here is capital. Now I'm going into this into some detail because you'll see as we progress through this material that this concept of diminishing marginal product of capital is actually hugely important in some of the most important theoretical models of economic growth that macroeconomists have developed. We're going to see that this characteristic of production actually has some very profound implications for the very nature of economic growth. All right, so that's diminishing marginal product of capital. The second characteristic of production functions, indeed the second characteristic of production in the real world that we observe, is also a diminishing marginal productivity concept, but in this case it relates to labour. So there is, in the real world, a characteristic of production known as the diminishing marginal productivity of labour. And I'll use capital L now for labour. And this production table illustrates it, and I'll leave it to you to work through. What I've done in this table is I'm holding capital constant at 2 units of capital, and then I'm varying labour from 1 to 2 to 3 to 4, recording the amount of production each time. Check for yourself that this indeed is consistent with diminishing marginal productivity. We are getting more output from increasing labour, but the amount of extra output we're getting is diminishing. Now for our third characteristic of real-world production, if you like, the third characteristic that any production function we work with should be able to represent. This is quite different, this third characteristic, from the diminishing marginal productivity of capital and diminishing marginal productivity of labour. In this third characteristic, what I'm doing is now varying both labour and capital. The only thing I'm holding constant here are those secondary factors of production. And so I've been able, by doing this, by varying labour and capital, simultaneously, I can, as you can see, complete the whole production table. So for all combinations of labour and capital, here I've recorded the resulting output. And I want you to focus on these numbers here, because these numbers show something quite profound. So the first number represents what happens when I have 1 unit of labour, 1 unit of capital. The second number, I now have 2 units of labour, 2 units of capital. Third number, 3 units of labour, 3 units of capital, and then 4 and 4. And I want you to look at those numbers in red and see if you notice something. What you're looking at is a characteristic of production known as constant returns to scale. And constant returns to scale is an observation about production that says the following. If we scale up the amount of labour and capital by the same factor, you're going to get exactly the same scaling up of production. Now, we often use the Greek letter lambda to represent that factor. For example, when I write lambda equals 2, what I'm actually saying is I'm going to take an amount of labour and an amount of capital, and simultaneously I'm going to double both of those primary factors. So that's like going from 1 to 2. 1 unit of labour to 2 units of labour, 1 unit of capital to 2 units of capital. And have a look at those two numbers. I get exactly twice the amount of output. And that's what we mean by constant returns to scale. If I scale up both factors of production by the same scaling factor, in this case 2, I'm going to get exactly the same scaling up of production. Same thing happens when I go to 3 and 3. I'm now getting 3 times the production that I had when I had just 1 unit of labour and 1 unit of capital. So constant returns to scale is an important characteristic of production in the real world. It doesn't hold always, but it holds often. And we often embed this concept in our formal models of the production function. So let me just give that just a little bit more structure for you, because this is a concept that is going to be very important for us. So CRS is my notation for constant returns to scale. And here's a formal definition of it. If both capital and labour, and please remember that this is different from that diminishing marginal productivity where we held one of those factors fixed. Here we're varying both primary factors, but again, I won't write it down, but please be aware that we're holding secondary factors constant through this. If both labour and capital are scaled up, let's write it like this, by some multiple or some factor, and I'll use the Greek letter lambda, as my shorthand notation for that factor, the implication of that is we will get exactly lambda times the output. For example, lambda equals 4, you're going to get 4 times the output after we've quadrupled the amount of capital and the amount of labour. All right, this has all been a bit abstract, so I'd certainly like to emphasise that we are talking about real world events here. We are talking about firms and their combination of factors to produce output, but I am aware that it is a little abstract when you see it like this. And for those of you who are unfamiliar with economic models, it does take a bit of time to get used to making the bridge between the abstract way we write down these concepts and what's happening in the real world. But as I keep emphasising, we see this going on around us all the time, firms bringing together factors of production to produce output. One useful way of thinking about what we're seeing here is to move away from the production table, which is a bit cumbersome to work with, and instead illustrate visually what's going on. So what you're looking at here is another way of representing a production function using what's called a surface chart. So it's a three-dimensional plot of this concept of the production function. And so what we're doing here, similar to our last production table, is as we move along this axis, we're varying the amount of capital. As we move along this axis, we're varying the amount of labour. And then the height of this surface is giving us the amount of output. Let me just explore that a little bit more, because I'm going to come back to this surface chart and show you something really important very, very shortly. But to do that, I want to introduce you to the mathematical representation of the production function. You can see that in the centre of this slide. Most of what you're looking at is going to be fairly familiar to you, with one exception. So on the left-hand side, lowercase y represents real gross domestic product. On the right-hand side, capital and labour. I'm using lowercase letters because there's a convention in macroeconomics to use lowercase letters when we're talking about real variables. So capital and labour, our primary factors of production, influence or help to determine the total amount of output. The F here is just represents function. So what I'm saying here is the amount of the flow of output that the firm produces is a function of the primary factors of production. So function means bringing together, combining. That leaves one part of that expression that I haven't talked about yet, and that's capital A. Capital A is, it's a number. And the value of that number represents all of those secondary factors, or if you like, represents the combined influence of all of those secondary factors of production. It's everything that could possibly influence firms' ability to produce output other than capital and labour is represented in summary form by the value of A. So what you're looking at here is actually a very rich way of thinking about firms' production. Firms exist to bring together the primary factors of production in order to produce output. It's not just the total amounts of the primary factors that influence firms' ability to produce output, firm's ability to produce output is also going to be influenced by all of these secondary factors of production. And remember, this could be anything at all that influences production, like technology, like skills, like climate. I'm sure you can think of a great many other things. What this means is that you may have two firms, or indeed two economies, that have equivalent amounts of capital and labour, but their ability to produce output may still be different if the secondary factors of production, or as these are sometimes also known, I might as well introduce the term now, total factor productivity is another term for these secondary factors. If total factor productivity or these secondary factors differ, then the same amounts of capital and labour can yield different amounts of output. And if we go to this surface chart, we can illustrate that very nicely. What I've done to construct this surface chart is to take a value of total factor productivity equal to 2. Should I vary that, for example, should it fall to 1.4, you can see that the production surface shifts down. And that's exactly what's the whole point about total factor productivity. The same combinations of capital and labour are now producing less output because there has been a fall in these secondary factors of production. That's how it looks when we have 2. That's how it looks when we have 1.4. The height of the production surface is itself changing. And so the theory that we're about to explore over the next little bit of our course is going to bring all this discussion together in a much more systematic way. We're going to bring together this idea of the production function. We're going to bring together these characteristics of the production function, constant returns to scale, diminishing marginal productivity. We're going to bring in the effect that changing total factor productivity can have, and we're going to do it all in a very systematic framework that will enable us to say some very, very profound things about the very nature of long-run economic growth.